5.1, which dealt with exponents. So I'm just going to do a few problems. Please feel free to follow along. Make sure that you have some scratch paper out in front of you. Once I put down the problem, I would suggest stopping to actually work out the problem yourself, by pausing the video, and then once you are done, start the video back up to see if your solution matches the one that I will work out. So we do want to remember that we do use the product rule, the quotient rule, and the power rule. And we actually use these three rules to tackle all of these problems. So to begin, let's start off with, how about the quantity of a to the third? And that is going to be raised to the third power. And then I'm going to have the quantity of a squared raised to the third power as well. So in this situation, what I would suggest doing is I notice the power rule happening right here. The power rule, remember, is enacted whenever you have an exponent raised to another exponent. So in this case, I would have a to the 9th times a to the 6th. And here is where you can use your product rule. Remember, your product rule is when you have two exponential expressions that have the same base. So in this case, since both of them have a base of a, it means that I can simplify it further by combining them. And in this case, the product rule tells you that this can be a raised to the 9 plus 6, or in other words, this is equal to a raised to the 15th power. All right, so that was our first example that we're going to look at. Let's see here. A little bit more of a complicated one. Let's go ahead and take a look at the quantity of -6 times a to the 5th. All of this is over to b to the 7th, and this entire expression will be raised to the third power. So again, before I actually start cleaning anything up, well actually, if you notice on the inside, if we take a look at all the bases here, so we have one value has a base of 6, one value has a base of a, and one value has a base of b. So in this situation, there's really not much cleanup that I can do. I don't see an opportunity to either use a product rule or a quotient rule. But I do see that I have the ability to use the product rule in some way, shape, or form. So this is telling me that I can go ahead and distribute that cube to each item, to each exponent in here. So recall that the -6 is an exponential expression. It just has an exponent of 1. And we tend not to see the exponent of 1. It's almost redundant, or it's just not necessary to show it. So in this case, we would have -6, and then this would be 1 times 3, so that gives us 3. A raised to the 5 times 3, which is 15, all over b raised to the 7 times 3, which is going to give you 21. I am okay to say that this is my final solution, so think about why I'm okay to say that. Notice that each of the bases is only represented once, so there aren't a bunch of exponential expressions with the base of b everywhere. None of the exponents are negative, and please, I know that your eye might be pulling toward the negative sign out in front of 6, but please note that that negative is attached to the base and not to the exponent. It's okay to have a base that has a negative value. It is not okay for your final solution to have a negative in the exponent. Okay, so the next one that I'll go ahead and take a look at with you will be, let's look at a really quick one. So I'm going to scroll this up out of the way for a fresh sheet. Okay, so let's take a look at the expression of the negative times the quantity, x times y, raised to the 0. So we do want to be careful here, and we did look at one like this similar in class. So notice in this case, the only thing that is being raised to the 0 power is this quantity. Okay. The negative has been left on the outside, so if you want to think about it in a different way, that negative is actually a negative 1 that wants to multiply itself onto your final answer. Okay, so remember order of operations. So with order of operations, I am telling you straight away, hey, take care of whatever has the exponent attached to it. So as you run through, the negative 1 is just going to move down to the next line, and you're going to evaluate the quantity of x times y raised to the 0 power. This becomes 1, as we had discussed in class. And then 1 times negative 1 just gives you negative 1 in this case. Alright, so let's keep going. A quick rehash then. Another problem that I think might be good for us to see would be 12 times h raised to the negative 9. So note in this case that there are no parentheses. So ask yourself, where is this negative 9 attached to? What base is it attached to? So is it attached to the 12 and the h, or is it just attached to the h in this case? And hopefully what you're saying is, well, since there are no parentheses around it, I know that the 12 has an exponent of 1. So here is where we kind of run through our list. Do you see any sort of opportunities to use the product rule, the quotient rule, or the power rule? And hopefully you're kind of saying, well, no, there isn't. So in order to find out the final solution, we're really just going to say we need to make everyone happy. So in other words, we need to deal with the negative exponents that we're looking at. So 12 is happy right where they are. Okay, 12 has an exponent of 1, and specifically a positive 1, so we don't want to move the 12. The h, on the other hand, is, as we had said in class, that moody teenager that we need to try and make happy again. So we're going to allow them to slink back into the basement to, I don't know, binge watch whatever current television show they're binge watching these days, right? So in this case, here is your final solution. Again, notice that the bases are only represented in one spot, so there are not multiple exponential expressions with a base of h. And all of the exponents that you see are positive. All right, so we're going to just do one more. Let me clear this out of the way. And I think a good one for us to look at will be, well, let's try and make this a little bit challenging. So let's take a look at the following. I want to look at the quantity of a raised to the negative 2 times b raised to the 5th power all over 5b squared. And this entire expression is going to be raised to the negative 3. So one of the first things that I want to see is I would adhere to your order of operations. So in this case, I noticed that I have a couple of expressions, or a couple of exponential expressions that have the same base. There we go. Okay, so what rule can you use here in order to clean everything up? And again, this is very Blue's Clues, but hopefully you're screaming at your computer, the quotient rule! And then I would say, very good, everyone, so let's enact it. Only we're not going to sing some sort of silly song because I didn't have time to write one and produce one. So in this particular case, then, we would have b to the 5th over b to the 5th. In other words, let's do an aside here so we can kind of see my thought process. I'm just focusing on this portion of the expression. So my quotient rule says that this is b raised to the 5 minus 5, or b to the 0. And do we recall what b to the 0 is equal to? Again, you should be screaming 1 at your computer screen. Anyone in the room or the near vicinity is probably looking at you funny. So if we are left with that, then we have a raised to the negative 2 divided by 5. And then we still have that negative 3 exponent. Now we can go ahead and kind of share it in a sense. So this will have an exponent of negative 3 multiplied with it because we're going to use the power rule. And this will also experience the same thing because, again, what exponent does the 5 have if you don't see it? Again, it's a 1. Okay, so far so good. So a to the negative 2 raised to, or times the negative 3, is going to give you a to the 6 all over 5 raised to the negative 3. So there is one other slight modification. Remember that we do have that 5 raised to the negative 3 is unhappy downstairs, so we need to move it up in order to make the sign on the exponent positive. So my final solution will be 5 cubed times a to the 6th. Okay. If you want to evaluate it further, 5 cubed is 125, and this would be a to the 6th. Okay, so, and there's our final solution. I hope that this video was helpful, and if you have any questions, please let me know.